Welcome to the long run behavior video part 2. This is going to take you through the homework assignments that I asked you to try on your own. One of the ones I asked you to try was number 3. When you're looking at the long run behavior, I told you the first thing you want to do is look at your leading coefficients. So my leading coefficients here are x over 3x to the third. And I want to see if these will reduce to a 1 over x or a 1 over x squared. Well, it reduces to 1 over 3x squared. The 3 isn't going to affect the long run behavior. It only affects the vertical. And since we're looking at long run, I'm going to say that this is going to resemble y equals 1 over x squared. Because it resembles y equals 1 over x squared, the asymptote's going to be at y equals 0. Because it resembles a 1 over x squared, I know the long run behavior will be above the line y equals 0 on both sides. To write the behavior statement, we start off with as x approaches positive infinity, moving as it moves to the right, my graph is going to be above the line y equals 0. As x moves in the negative direction to the left, my graph will also be above the line y equals 0. Remember, these little plus signs just mean above. If I put a negative sign, it means below. Okay, so that took you through number 3. The next one I asked you to try on your own was number 6. On number 6, when we went and looked at the two coefficients right here, and I cancel them out, they do not simplify to a 1 over x or a 1 over x squared. And when this happens, I told you that you needed to go divide. So I'm going to come over here, and we're going to do some division. So I have 2x squared plus x. And I'm going to divide that into negative 4x squared minus 2x plus 3. So I want to know how many times will 2 go in to a negative 4. It'll go in negative 2 times. And then I'm going to multiply. Negative 2 times 2, negative 4x squared. Negative 2 times 1 is a negative 2x. And then I'm going to remember to subtract. And when I subtract, my x squares are going to go away, and my x's are going to go away, and I'm going to bring down my 3. So we're left with y equals, remember this is your new numerator, 3 over 2x squared plus x minus 2. So this piece right here is what I need to take the leading coefficients and reduce. So if I reduce that, I get 3 over 2x squared. And again, the 3 and the 2 aren't important, so it's going to look like a 1 over x squared. And then I'm going to have a horizontal asymptote at negative 2. So I'm going to go put me a horizontal asymptote at negative 2. Okay. And then because it's a 1 over x squared, the end behavior says I'm going to do the same thing. Because it's positive, I'm going to be above on the left and the right. So our behavior statement is going to be very similar to the one we just did. As x approaches positive infinity, my graph is going to be above negative 2. So that's how I write it, negative 2, and I'm above. As x approaches negative infinity, as I move to the left, my graph is still going to be above negative 2. Okay. The next one I asked you to try on your own was number 9. Let's go look at number 9. On number 9, we're going to start off the same way we did before. Excuse me. We're going to go do our division. And when we divide, we're going to have 2x squared divided into negative 2x to the third plus 3x plus 4. So how many times will 2 go into negative 2x to the third? That's going to actually go in a negative x time. So 2x squared times negative x is going to give me negative 2x to the third. And I'm going to go subtract, and I'm going to get 3x plus 4. So when I come over here to the side and rewrite it, we get y equals 3x plus 4 over 2x squared minus x. We look at our leading coefficients again, and I reduce. So I get 3 over 2x The x squared cancels because of this x up here. The 3 over 2 doesn't really matter, so it's going to look like a 1 over x. And the horizontal asymptote is going to be here at the line, y equals negative x. So I'm going to go graph my line, y equals negative x. Because it's a y equals 1 over x, the behavior pattern says for 1 over x, we're above the line on the right, and we're below the line on the left. So I'm going to go write my behavior statement. As x goes off in the positive direction, my graph is going to be above the line y equals x. And as x goes off into the negative direction, my line is going to be below the line, y equals negative x. Okay. The next 4 problems I asked you to try were 10, 11, 12, and 14. So I'm going to go through those also. On number 10, 11, 12, and 14, they're all mixed up, so you have to actually go through the steps and think. So the first thing you're always going to look for is see if it reduces to a 1 over x or a 1 over x squared. If it doesn't, then you divide. So this one doesn't because these cancel out completely. So I'm going to come over here and I'm going to divide, just like we were earlier. And I'm going to say how many times will x go into x, and you're going to tell me once. And 1 times x is x, and 1 times negative 1 is negative 1. And then we're going to subtract. And x take away x goes away. 1 minus a negative 1 is actually a 2. So we're going to have y equals 2 over x minus 1 plus 1. They don't ask me to write what it's going to look like, but I'm going to do that. It's going to look like a y equals 1 over x, and it's going to have a horizontal asymptote at y equals 1. It looks like 1 over x because 2 over x reduces to 1 over x, and it has a horizontal asymptote at y equals 1 because we had a plus 1. So I'm going to come over here and graph it. Here's my horizontal asymptote at y equals 1. Since it's a 1 over x, I'm above on the right and below on the left. So my behavior statement, as x goes off to the right, the graph is going to be above the line y equals 1. And as x goes off to the left, oh, that's a crazy infinity sign, the graph is going to lie below the positive 1 line. Right, number 11. On number 11, if I go in and I look at my leading coefficients, it actually reduces. Negative 4x over 2x squared is going to reduce to a negative 2 over x. Again, we don't really care about the negative 2. It's going to look like a negative 1 over x. Because I didn't have to add anything out here, because I didn't have to do any division, my horizontal asymptote is going to be at y equals 0. So if you don't have to divide, your horizontal asymptote is going to stay at that y equals 0 line. Because it's going to look like a negative 1 over x. Instead of being above on the right, I'm actually going to be below on the right. And 1 over x says always do the opposite. So I'm going to be on the left-hand side, I'm going to be above. These arrows will always be opposites for 1 over x's. So my behavior statement, as x goes off to the right, to positive infinity, my graph is going to be below the 0. And as x goes off to negative infinity, the left of the graph, my end behavior is going to be above the line, y equals 0. All right, let's go look at 12. On number 12, again, we always start off by looking and seeing, can I reduce to get what I want? So let's go look. So I'm going to go write this down, 4x to the 5th over 2x to the 7th, and that's going to reduce to 2 over x squared. Again, the 2 doesn't really matter. So it's going to look like a 1 over x squared with a horizontal asymptote at y equals 0. So I'm going to go draw in my line, y equals 0. Because it looks like a positive 1 over x squared, it's going to be above on the right and above on the left. If it's a 1 over x squared, the end behavior does the same. If it's a 1 over x, like we had here and here, then they do the opposites. But this one's a 1 over x squared, so the end behaviors do the same. As x approaches positive infinity, we're above the 0 line. As x approaches negative infinity, we're still above the 0 line. And I told y'all not to do 13 for time reasons. I just took a couple out. And now we're going to go look at 14. So on 14, if I try to reduce, negative 2x to the third over negative 2x squared does reduce, but it reduces to x, not 1 over x, and not 1 over x squared. So again, we have to go do our division. The number on the bottom goes outside. The number on the top goes inside. So how many times will negative 2x squared go into a negative x to the third? And we're going to say it goes in x times. And then I'm going to remember to multiply. Negative 2x squared times x is going to be a negative 2x to the third. And then we're going to subtract, and I'm going to bring down my negative 5. So we have y equals negative 5 over negative 2x squared plus x. So a negative over a negative is going to cancel. So I'm going to have 5 over 2x squared. So it's going to look like a positive 1 over x squared with an oblique asymptote at y equals x. So the line y equals x goes right through the middle because 1, 1, 2, 2, 3, 3, 4, 4, because y will always be x. And it's going to look like a positive 1 over x squared, which means they're both going to be above on the right and the left. So when I write my end behavior statement, as x goes to the right, we're going to be above the y equals x line. And as x goes to the left, I'm going to be above the y equals x line. Okay, I hope this helped.